Okay, in this video, we are going to discuss the elimination method, which is sometimes also called the addition method. And I have the steps written here on the side. So if you need a minute to copy those down, just pause the video to do that. In the first step, it says, write one equation above the other, lining up corresponding variables and the constant. Then the second step is we want to rewrite the equation so that one of the variable has opposite coefficients. So what I mean by that is we want the y variable maybe to have a coefficient in one equation of -3 and the other equation as +3. Or maybe we want the x variable to have a +7 in one equation and a -7 in the other equation for the coefficient. Okay, and the reason that we were going to do that is so that when we add them vertically, it adds up to 0. And then in step 3, we're going to add vertically and eliminate variable so that it adds up to 0. And then step 4 is we're going to solve for the remaining variable. And then we're going to, for step 5, substitute back in to find the second variable. And then, of course, the last step is to check your answer. So looking at this first example, going through step number 1, it says write the equation above the other, lining up corresponding variables and the constant. So if you notice, these are already lined up. My x's are above each other. My y's are above each other. My equal signs are lined up. And then I have my constants lined up. So everything is already lined up. If it's not, you have to rearrange the equation so that everything is lined up. Okay, then the next step says rewrite the equation so that one variable has opposite coefficients. Now, it doesn't matter which variable you pick, and with experience, you'll notice sometimes one's easier than the other, but again, that comes with experience. But other than that, it really doesn't matter which one you choose. Because I have experience doing this, I can see that the easier variable to eliminate first would be the y. So the top equation will be equation 1, the bottom equation will be equation 2. I'm going to take the entire equation 1 and I'm going to multiply it by 2. 2 times equation 1, that's going to give me -10x minus 6y is equal to 24. I'm multiplying everything by 2. Now, that makes my y coefficients have the same number but opposite signs. So what I'm going to do now is just rewrite down equation 2. So we've completed step number 2. We rewrote the equation so that one of the variables has opposite coefficients. Okay, now step 3 says to add them vertically. So now I'm going to add these two equations. So when I take -10x and a +4x, that's going to give me a -6x. When I add the -6y and the +6y, I get 0y, and that disappears. And then the 24 and a -6 gives me an 18. Now I've added them vertically, so then step 4 is to solve for the remaining variable. So now I'm going to divide both sides by -6 so I can solve for x. So I've got my first variable, x is -3. Then in step 5, we're going to substitute back in to find the second variable. Now, it doesn't matter where you substitute it back in. It truly doesn't matter. You can pick equation 1, equation 2. I'll pick equation 1. I'm going to plug in -3 into equation 1. So that means I'm plugging it into this x right here. I'm going to plug in x is -3. Now I have -3y is equal to 12. And now I can solve this for y. So I've got 15 minus 3y is equal to 12. I'm going to subtract 15 from both sides, so that gives me -3y is equal to -3. So y is 1. So there's my second variable. So if I were to graph these on my calculator, if I would want to check, I would graph both lines, equation 1 and equation 2, and then where they cross would be the point -3, +1. This should be where their intersection point is. Okay, example 2, we need to make sure that everything's lined up. So if you look, my y's are lined up, my x's are lined up, my equals are lined up, and then my constants lined up. So this is already set up nicely for us. And if you notice, in step number 2, it says rewrite the equation so that one variable has opposite coefficients. This step is also completed for us because I have +4y and a -4y. Those already have opposite coefficients, so that I'm good there. I can skip step 2 as well. So I'm going to go straight to step 3 and add vertically. So when I add these up, I get a -4x and a -2x. That gives me a -6x. The +4y and the -4y give me a 0y, and that disappears. -4.8 plus 0.6 will give me a -4.2. The next step is to solve for the remaining variable, so I'm going to divide both sides by -6, and that will give me +0.7 because the negative divided by a negative gives me a positive. So here's my first variable. For step 5, now I have to go back and substitute in to find the second variable. So I'm going to plug 0.7 into one of these equations. I'll just use the first equation, but it doesn't really matter. So I'm going to have -4, and then I'm going to plug in 0.7 plus 4 times y is equal to -4.8. So this gives me a -2.8 plus 4y is equal to -4.8. I'm going to add 2.8 to both sides. When I do that, I get a 7.6. And then divide both sides by 4. And I get 1.9. So there is my other variable. Y is 1.9. So if I want to check this on my calculator, I can graph both lines. And then I could just make sure that it crosses at the point 0.7, 1.9. And don't forget, the other way you can check it is to just actually by hand plug 0.7 and 1.9 in for x and y into both equations to make sure it gives you a true statement for both equations. Okay, in the next 2 examples, I have special cases. So the first step is to make sure everything is lined up. All my x's are lined up, all my y's are lined up, and my constants are lined up. So this one's good. Then the next step is to rewrite one of the equations or both of the equations in a way so that one of the variables has opposite coefficients. So in the previous 2 examples, we eliminated y. So let's try eliminating x this time. I'm going to multiply the first equation by -10. That will give me a -40 for one coefficient of x, and then the bottom equation, that will give me a +40x. So I'm going to take equation 1, and I'm going to multiply by -10. That's going to give me -40x minus 50y is equal to -60. Then I'm going to carry down my second equation. And then I'm going to add these vertically. So the 40x and the -40x adds to 0. Then the -50y and the +50y also adds to 0. And then I get -60 and -60 is a -120. Now, here's why it's a special case. I have a statement that is not true. 0 does not equal -120. When you run into this case where you have a statement that is false, this is the case where you have no solution. If you were to graph these 2 equations, you would find that they were parallel lines. And when you have that case, this kind of system of equations, when you have parallel lines, that is called inconsistent. Okay, the next special case (4x plus 5y is equal to 6), and then 40x plus 50y is equal to 60. So this is very similar to what we did up here, only notice this is a positive 60 down here instead of a negative 60. So I'm going to do the same thing. I'm going to multiply the first equation by negative 10. And that way we have a positive 40x and a negative 40x. So when I multiply the first equation by negative 10, I'm going to get negative 40x minus 50y is equal to negative 60. And then I'm just going to carry the second equation down. When I add those vertically, I get 0 for the x's, 0 for the y's, and the negative 60 and the positive 60 add up to 0 as well. This is a true statement. 0 is equal to 0. When you have a true statement, this is the case where you have lines that lie on top of each other. It's the same line. So this is the case where you have one line graphed, and then the other line lies right on top of it, so they cross everywhere. This is called a dependent system, and this is where we would have infinite solutions, because any point that lies on one line will work for the other line. Now, if I want to write out a way to list all those points, then I would solve for y. It doesn't matter which one you would solve for. I'm going to pick the 4x plus 5y is equal to 6, and I'm going to solve this for y. So I'm going to subtract 4x from both sides, and then divide by 5. So I have 6 minus 4x over 5. So I would write the list of all ordered pairs that work for these two lines as x, and then y is 6 minus 4x over 5. Also, by the way, if you have a system like in example 1 where it just crosses in one place, and you just have one ordered pair as your intersection point, then this is called an independent system. I forgot to mention that earlier, so I want to add that in. Okay, now, solving a system with fractions. We're going to do the same thing we've been doing so far, follow all the same steps, only we're going to add one extra step in. We're going to clear the fractions first to make it easier, because this would be really messy to try to solve this with the fractions. So if I look at the first equation, I'll call this equation 1 and equation 2. For equation 1, I have 2, 6, and 9 as my denominators. I can use 18 and multiply all of those terms by 18 to clear those fractions. So I'm going to take equation 1 and I'm going to multiply by 18. When I multiply 1/2 x by 18, that's going to give me a 9x. When I multiply negative 1/6 y by 18, that's going to give me a minus 3y. And when I multiply 1/9 by 18, that's going to give me a 2. So I just cleared the fractions. So now let's look at equation 2. And if I look, 5, 2, and 30 are all in my denominator, and I can use 30 to clear all of those. So I'm going to multiply equation 2 by 30. When I take 1/5 x times 30, that's going to give me a 6x. When I take 1/2 y times 30, that's going to give me a 15y. And when I take 7 over 30 times 30, that's going to leave me with just 7. So now I have these two new equations with the fractions clear, which will make it so much easier. Now if I look, I want to make sure that my x's and y's and my constants are all lined up, and they are. And now I want to try to figure out how else can I rearrange this so that I have one of the variables with opposite coefficients. If I look at my y's, and if I take that equation that's in red and I multiply by 5, that would give me a negative 15y and a positive 15y for my y's. So I'm going to multiply this equation here by 5. So that's going to give me 45x minus 15y is equal to 10. Now the equation that's in blue, I don't have to do anything to it, so I'm just going to carry it down. And now I can add them vertically. When I add them vertically, I get 45x plus a 6x. That gives me a 51x. The negative 15 and the positive 15 disappear. And then I have 10 and 7 is 17. Now I can divide both sides by 51. When I do that, I get x is 1/3. So this is my first answer. Now I have to use that to plug back in to figure out what my y value is. So it doesn't matter which equation you plug it back into, just pick one. I'll pick the first one in red. So I'll take 9 times 1/3 minus 3y is equal to 2. Let me put an arrow here so we can follow in the notes where we're going with this. So 9 times 1/3 gives me 3. And then I have 3 minus 3y is equal to 2. I'm going to subtract 3 from both sides. So that gives me a negative 1 on the right, and then I divide both sides by 3. So y is going to end up being positive 1/3 as well. So then if I want, I can graph these and make sure that they intersect at 1/3. This would be the ordered pair where they intersect 1/3, 1/3. Okay, example 2 for doing fractions. I'll list this as equation 1. This is equation 2. So I want to clear the fractions first. So if you look in the first equation, I have 3, 6, and 6. So I can use 6 to clear those fractions. So I'm going to take equation 1 and multiply by 6. So when I take equation 1 and multiply by 6, that's 6 times 1/3 x. That gives me 2x. Then 6 times 1/6 y gives me plus y. And then 6 times negative 1/6 gives me a negative 1. Then in the second equation, I'm going to multiply everything by 36. 3, 4, and 36 all divide into 36. So let's use 36. So when I take 36 times 1/3, that's going to give me 12x. When I take 36 times negative 1/4 y, that gives me a negative 9y. And when I take 36 times negative 1 over 36, that's going to give me a negative 1. So now I've cleared my fractions, and I have 2x plus y is equal to negative 1, and 12 minus 9y is equal to negative 1. So what I'm going to do is I'm going to figure out how can I make these two equations have a variable so that they're opposite coefficients. So I can either take the first equation and multiply it by negative 6, because that would give me a negative 12x. Or I can take the first equation and multiply by positive 9. Either one is fine. No matter what you do, it's going to come out the same. I'll take the first equation and multiply by negative 6. When I take the first equation and multiply by a negative 6, that's going to give me a negative 12x minus 6y is equal to positive 6. The second equation, I don't have to do anything to it. I can just carry it down. There are times where you will have to multiply both equations in order to make it so that one of the variables cancel out. It just so happens that the examples I picked in my notes, that didn't happen. But there are times where you're going to have to multiply both equations to make it so that one of the variables has opposite coefficients. Okay, so now I'm going to add these. My x's disappear. I get a negative 6y and a negative 9y. That gives me a negative 15y. And when I take a positive 6 and a negative 1, that gives me a positive 5. So I'm going to continue to solve for y. That gives me y is negative 1/3. Because I got 5 over negative 15, and that reduces to negative 1/3. So this is one of my variables solved. Now I have to go back in and plug it in for one of the other equations to solve for x. So I'll plug it into this equation here. I have 12x minus 9 times y is negative 1/3 is equal to negative 1. So I have 12x, the negative 9 times the negative 1/3 gives me a positive 3. I'm going to subtract 3 from both sides. So that gives me 12x is equal to negative 1/4, which means x is going to be negative 4 over 12, which would be negative 1/3 when we reduce it.